This is a movie about how to write ionic formulas. The basic thing you need to remember about writing ionic formulas is that you're trying to get the right ratio of ions so that the charges will cancel. Ionic compounds don't have a charge, and so when we have this basic ionic compound like potassium iodide, we have to look up basically the charges on these ions and write the formula for the ions, and then use that to figure out the formula. Okay, so potassium, as we see, is in group 1, so it forms a +1 charge. And iodide is in group 17, it forms a -1 charge. So we can use that to write our ions. So I can write my K with a +1 charge and my I with a 1 minus charge. And there's several ways to do this. One way is called the crisscross method, where you write the ions, then underneath you write the elements together, and then you crisscross whatever the charges are, you bring them down as subscripts on the compound. You just crisscross it. So whatever the charge is on I, you bring it down and put it on a subscript as K, and then whatever's the charge on K, you bring it down as a subscript on the iodide. So we end up with Ki as the formula for potassium iodide. Now, a better way of doing this is the actual look at it and reason through it and figure out that, okay, I'm trying to get the charges to cancel, and so K is a +1, I is a -1, a +1 and a -1. Of course, you add them together, that equals 0, so they already cancel. Okay, some compounds are going to do that. That's like the next compound, strontium, is in group 2, right here. So it has a +2 charge. And oxygen, oxide, is in group 16. It has a -2 charge. And so we have Sr with a +2 and oxygen with a -2. Now, the crisscross method doesn't really work with this one, because if we do the crisscross, if I bring that down here and that one down here without the plus or the minus, I get Sr2O2, and that's incorrect because it's not reduced down. Okay, if we notice that's a +2, that's a -2, they already cancel, and so we don't have to do anything. We can just put them together. So SRO would be the formula for strontium oxide. If we look at something like magnesium fluoride, magnesium is also in group 2, so it has a +2 charge, and fluoride is in group 17, so it has a -1 charge. So I write the ions, Mg +2, and then my F with a -1 charge. I can do the crisscross on this one, but I can also just look at that and say, okay, this is a +2. This is my total charge over here. I have a total of a +2 positive charge and a total of -1. I don't have enough negative charge, and so I have to add another fluoride. And when I add another fluoride, like this, I'm just showing you another method. Okay, now adding that other fluoride gives me a total -2 charge. +2 and -2 combine together to make 0. So that is my ions that I need to make a neutral compound. And so the formula for magnesium fluoride is MgF2. Okay. Now that one I could have also did the crisscross method, so let me show you that real quick. Okay. So I write the ions and I write the elements together without their charges. Then I crisscross the charges without the plus or the minus, and I bring them down. And so I get Mg1, but I don't write the 1, F2. And that would be the formula for magnesium fluoride. Let's try one that's a little more difficult, aluminum sulfide. So aluminum is in group 13. It has a +3 charge. Sulfide is in group 16. It has a -2 charge. So aluminum +3, sulfur -2. Notice I have total +3 positive charge and total -2 negative charge. I don't have enough negative charge, so I need another sulfide. So that gives me, remember that the negative monatomic ions are always the ones that end in IDE. And so I get a negative 4. So now I have too much negative charge. I need more positive charge. I have to add another aluminum, because that's the only thing I can add is aluminum or sulfur to make this compound. And so now I have a plus 6, and I need I don't have enough negative charge, so I need another sulfur over here. So that gives me a negative 6, and now it cancels, and so that's basically my formula. I need 2 aluminum ions and 3 sulfur ions, so it's going to be Al2S3. Okay, and of course if you do the crisscross, you're going to get the same answer. Just remember that the crisscross doesn't always work. Take the 3 down, put it on the S, take the 2 down, put it on the Al. So we get Al2S3. And that's a 2 right there. Yeah. Okay, sometimes we might have an ionic name with a Roman numeral. The Roman numeral basically tells us that's a transition metal, and that Roman numeral is the charge on that ion. So we don't have to look up nickel. We already know that nickel has a +3 charge because that Roman numeral tells us. We just have to look up the oxide, which is oxygen. So oxygen, here's a -2. And so then we can do our crisscross method. We can bring the 2 down on the Ni and bring the 3 down on the O. So we get Ni2O3. Okay. And that's the formula for nickel 3 oxide. Titanium 4 oxide. Titanium is Ti. So it has a +4 charge. We get that from this Roman numeral right here that tells us the charge on the titanium. And the oxide, of course, is oxygen and has a -2 charge. Oops, wrong way. So -2. Now if I do the crisscross on this one, it also doesn't work because oxygen is a multiple. This -2 is a multiple of this +4. So if I do the crisscross, I get a Ti2O4, and that's incorrect because for ionic compounds, for the formulas, you have to reduce those down to the lowest form. It's the simplest ratio of positive ion to negative ion, so that wouldn't work. I could reduce that down, divide both of the subscripts by 2 and get TiO2, and that would be correct. Or I could just look at that and say, well, how many oxides do I need to give me a -4? Well, obviously I just need 2 of them, so it'd be TiO2. This one, calcium phosphate, we have to recognize that phosphate, that 8 right there, tells me that this is a polyatomic ion. And so the polyatomic ions, you have to basically kind of memorize those so that you at least know they're a polyatomic ion, and you know to look those up on the polyatomic ion chart. So if I look and I find phosphate, phosphate is right here. It's a PO4 molecule with a -3 charge, so it's a 1 phosphorus covalently bonded to 4 oxygens, and the whole thing together has a -3 charge, and it behaves like an ion. Calcium is in group 2, so it has a 2+ charge, so I know that calcium is Ca with a +2, and phosphate is PO4 with a 3- or -3. And the main thing we need to watch out for when we're writing formulas that have polyatomic ions in them, if we have more than one of that polyatomic ion, we have to put it in parentheses. So we got to make sure that we keep the PO4 as PO4. And so we can do the crisscross on this one. Bring the 3 down, put it on the Ca, and bring the 2 down and put it on the PO4. But because I need 2 of those PO4s, I have to put that PO4 in parentheses. So I get Ca3, parentheses, PO4, close parentheses, and a 2. Okay? And you can always check your work. 3 times +2 gives me a +6. and 2 times minus 3 gives me a minus 6. That cancels out, so that tells me that that's a neutral compound, and that's more than likely the right answer. Okay, silver phosphate. One thing we have to watch out for on transition metals is that there are some of them that don't form more than one ion, and so they don't use Roman numerals with those. Like silver is a +1, zinc is a +2, cadmium is a +2, and bismuth is a +3. And this list is different from textbook to textbook, and there are others that only form one ion, but these are the most common ones. And so you just kind of have to memorize those transition metals that only form one ion and memorize what their charge is. So silver is Ag with a +1 charge. Then phosphate, right, is PO4 with a 3- charge. So we have PO4 with a -3 charge. And then we can do our crisscross on this one. Bring the 3 down, put it on the Ag. Bring the 1 down, put it on the PO4. Now, because there's only one of those PO4s, we're not going to put it in parentheses. It's just going to be Ag3 PO4. Here's another one. Here's another transition metal that only forms one ion, and so that's another one we have to memorize is zinc. So zinc is a +2 charge. Then phosphate is PO4 with a 3-. Okay. And instead of doing the crisscross, let's do the other method. We have a total of +2. This is a total. This is a -3. Okay. I don't have enough negative. I don't have enough positive charge. Okay. I got too much negative charge, so I need another zinc. Okay. So that gives me another +2. So that gives me +4. Now I have too much positive charge and not enough negative charge, so I need another PO4. Gives me -3. It gives me -6. And so I need another zinc. Gives me +2, so that gives me a +6. So now the charges cancel, the charges balance. Okay, get a +6 and a -6. So I end up with the formula being Zn3 PO4. And now I need 2 of those PO4s, so I'm going to put it in parentheses and put a 2 on the outside of the parentheses. And that is the formula for zinc phosphate. And that is how you figure out the formula for ionic compounds.